Hi, my name is Nick, and I am here to present the solution to problem D, fail fast. In this problem, you're given n automated tests that each have some cost and some probability of passing. Some tests may have a dependency. In this case, a test cannot be executed until its dependency has been executed. The cost of executing some sequence of tests is the sum of the test costs up to and including the first test that does not pass. If all the tests pass, the cost is 0. We wish to find a sequence of tests that minimizes the expected cost of running the tests. There can be at most 100,000 tests in this problem. So we first start by thinking about how to solve the problem when there are no dependencies. With some math, we can show that we want to process the tests in increasing order of c over 1 minus p. Intuitively, this means that we want to prioritize tests that have a low cost of being run or tests that have a high probability of failing. In an optimal solution, if we consider the test that has the minimum possible value of c over 1 minus p, we want to execute it as soon as possible. So once all of its dependencies have been executed, we should definitely execute that test immediately. This gives us the motivation to try to process the tests in order of priority. So initially, we will assume that there are no dependencies, and then give all tests the priority c over 1 minus p, and we will try to process them in that order. If we cannot run some test, then we will do a merge operation where we consider that test and its dependency as a single test, and we update its cost and probability of success accordingly. We'll update all of these tests and keep careful track of them in order to know what order to execute them in. In order to do this efficiently, we'll need some data structures. We can use our priority queue to sort the tests. We need a disjoint set data structure so we can see which tests share a parent dependency. And then we're also going to use a linked list within the merge tests to know exactly what order to run the tests in. So in the merge operation, we remove the minimum priority test from the queue. We'll update the priority value of the parent if relevant, take the union of that test and its children, update its parent, and then we'll concatenate the linked lists. So then the full solution is to initialize all of the data structures, process the minimum priority test unit as necessary, and then print each test unit in the order that they're executed. So overall, we can show that this algorithm runs in n log n.